Welcome to this video where we're going to be talking about a new feature in STimber that utilizes a wizard workflow to allow you to quickly and easily create single member models that you can then run analysis and code checks on using STimber. So here I'm starting with a blank STimber model, and you'll notice here that I don't have anything defined, but if I go to the Run menu, under the wizards we have a number of different wizards that exist in the program that have actually been shipped with the program. These are Python scripts behind the scenes, but as a user, you would not necessarily have to interact with that Python script. It has user prompts in the form of conventional windows and dialogues. And I'm going to go through this list here to the Create Single Member wizard. I'll open this up here, and it basically goes through a step-by-step process that allows us to define single member models, to perform a quick analysis and code check, without having to necessarily acquaint ourselves with the interface each time we use it. Here I specify the material category that I'm working with. I'm going to go with a glulam material. I can also choose the type of element, so there's a beam, column, truss, cable, tension only, or compression only member. And I can then select the design code that I'm using. In this scenario, I'll use the CSA 08619 code. I click Next to proceed. Here we can specify the material that we're using and even define our own. So if we don't find the material in this default list, we can always click on the ellipsis button to create a new material or modify the existing ones. I'll just go with this glulam material that we can see here. And for the cross section, again, we have a default list of timber cross sections in this scenario that are within my model or within my version of STimber. You may have a different list that you've customized yourself. If you don't see the section that you're looking for, again, just click the ellipsis button and you'll go right directly to this Define Sections dialog where you can create your own glulam sections or your own generic sections if that's what you want. So here, I'm just going to go with an example. I'll go with the glulam 130 by 532 section. And I'm going to click Next again. We can see now a rendering of our section. I can actually rotate this view if I'm interested as well. I can specify the length, so let me just say we'll keep it at 2.5 meters. And I can configure a number of other member-specific criteria. Things like the bearing areas, whether or not those are automatically created will depend on other elements that are connected to this. But we can also specify them ourselves as well as notches, bore holes, define deflection criteria, and more. You'll notice as well that I have the ability to define my end connectivity. So if I want this to be, for example, a pin beam, I can simply just release the MY and MZ, the strong and weak axis bending, on each end of the member. I'm going to click the Next button and continue on, and here I can set up my load cases and combinations. So let me just go with a couple load cases here. I'll create one that is just a self-weight load case, and I'll say let's apply this, and let me add a separate load case for live loads, which I'm not going to define any gravitational factor or self-weight factor for this one. I'll just click Apply and click OK. We can see those both in the list here. And I can also add load combinations as well. So when I click on this option, I click Add. I can choose how many load cases I want to contribute to this load combination, and I select them from this list. So I'll include my dead load and my live load, and we can enter the factors here. You'll notice that it by default will name it based off those factors in the contributing load cases. I can also choose which design checks are going to be performed with this load combination. So since this is unfactored, maybe I don't want to use the strength checks for this particular load combination. I can click Apply. And I could always make a copy and say, okay, well, let's use this as a base, and I'm going to just define some factors for these load combinations now, 1.25 and 1.5. Naturally, the name will update, and I can define my strength run here if I wanted to as well. Let's click Apply, OK, and now we have them all in this list. I can also choose whether or not I want my load cases to be ran for individual code checks, as well as define things like deflection and glulam shear load coefficient values. I'm just going to continue on and click Next. This is where I specify my load. For this scenario here, it's allowing me to specify a load case that I want to apply this load to. I'm going to go with the live load, and I can change what type of load this is. So let's go with a member line load and just use the magnitude of -4 kilonewtons per meter at the start and at the end. Maybe I'll zoom out so I can see what that looks like. And just click the apply button. That shows up in the spreadsheet now and can obviously be configured later at a different time as well. Next again is the last step where we specify essentially where we want to place this in the model. So it can be at the origin or some variation of that origin, different rotations as well. I'm just going to click the finish button. And we can see that STimber has dropped this into my model. Now the one thing I will need to do is just configure my support conditions. So let me just left click here with the tool window or with the selection tool. And I'll say that for this particular support, I'm going to have basically a pinned or fixed in translation support. And on the other end, I want it to be a little bit more customized. So I'll say custom DOF. And I'm going to allow for basically translation in the x-axis, but I'm going to restrain translation in the y and the z-axis, as well as rotation about the x-axis, since I don't want it rotating about that direction. And at this stage, we can go ahead and run our analysis in CodeCheck. So I'll click Run, CodeCheck, and we can go ahead and run this. And as we can see here, when I just scroll over to the side, we're getting a clean solution. It seems that we're not getting any utilizations that are causing failures in our members. So that is a good sign. We don't want that to happen. And I can also see more details on the CodeCheck results if I'm interested in that. So I can see the capacities, the factor strength values that are being used, and of course the actual analysis results if that was of interest to me. So I can look at member results and see things like my deflections or forces in my elements. And of course, if we wanted to revise a section or print off reports, that can also be easily done from this interface as well.